Welcome to my case study circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of lines using the Solid Edge software. Coming to the problem statement, here a line AB which is 80 mm long is inclined to HP at 30 degrees and to VP at 45 degrees. Draw the front and top views of the line and determine their apparent lengths and inclinations. So in the given problem statement, the true length of the line AB is given, which measures 80 mm. And also the true inclinations of the line is given, that is, with respect to the HP, the line is inclined at an angle of 30 degrees, and with respect to VP, the line is inclined at an angle of 45 degrees. So these are the true inclinations, that is, theta and phi. So we need to draw the top and front views of the line AB, and we need to determine their apparent length and the inclinations. So to begin with the procedure, we shall select the sketching menu, and then we shall select the line option and draw the XY line. It should be a continuous line of thickness 0.18 mm. So we will draw a line of arbitrary length measuring 0 or 180 degrees. So this is the XY line, and let us annotate this line using the text option in the annotation menu. The font style should be Times New Roman, and we shall annotate the reference line as XY. The planes above the reference line as vertical plane where the front view is recorded, and the plane below the XY line where the top view is recorded is the horizontal plane HP. So now the endpoint details is not given to us. So we'll just assume that one of the endpoint of the line, either A or B, is lying on the reference plane, that is XY. So for the convenience, we'll assume that the point A is lying on the XY line. So we can just choose an arbitrary point from this line, that is the XY line, and then begin drawing the true length of the line. So we'll assume that the point A is on the XY line. So the locus of the point A in both the front and the top views shall be overlapping on the XY line. So the true length of the line is 80 mm, and the angle of inclination of this particular line with respect to the horizontal plane is 30 degrees. So the line is ready, and now we shall draw the top view of the same line, which is 80 mm, and the angle of inclination with respect to the vertical plane is 45 degrees. So this completes the front and the top views of the line AB. So now we shall just annotate the line. So the front view is A prime or A dash. The locus of this particular line shall overlap on the XY line, and this particular point is B1 prime or B1 dash. And then this point is B. So A dash, B1 dash is the front view of the line AB, and A B2 is the top view of the line AB when it is inclined at an angle of 45 degrees with respect to the VP. So this is B2. So now we can draw the locus line of B in both the top and the front view. So for that, we'll select the line option and then select the dotted lines. So we shall draw the locus of B in both the front and the top views. So this is the locus line. So we'll just annotate the line. So this is locus of point B, the endpoint B in the vertical plane, and this is the locus of B in the horizontal plane. So now we'll follow the procedure. That is, we'll take the line option. So the thickness shall be 0.13 and it shall be a continuous line. So we will drop a perpendicular from B2 to intersect the locus line of A dash, so that we get the front view of this line AB2. So here this is AB2. So A dash B2 dash is going to represent the front view of this line AB2. So now we can go for arc by center point and select the first point as A and the second point as B2 dash and try to cut an arc to intersect the locus of B in the vertical plane, and then select the line option, and the thickness of the line is 0.50, and from the point A dash, the point of intersection of this locus line along with the arc. So this is the front view of the line AB. So I'll annotate this as A prime. So this is the front view of the line AB. So we can just measure the angles. So select the angle option. So this is the true inclination, which is 30 degrees, and the apparent inclination, which is 45 degrees. And this is the apparent length of the line AB, which is 56.57 mm. And then this is the true length. So the true length is always equal in both VP and HP. So now we will draft the top view of this line. So to get the top view, what is the procedure? We shall select the line option and ensure it is a projection line of thickness 0.13. So from B1, I will drop a perpendicular until it is intersecting the locus of A, because I need to get the top view of this line AB1. So I'll drop it here, and the locus of A is along the XY line. So this point is going to mark the top view of this line, that is B1. So AB1 is the top view of the line AB1, A dash B1 dash. So now we will go for the arc by center point. Select the first point and the second point as the end point, that is AB1, and then cut an arc to intersect the locus of B in the horizontal plane. So this point of intersection shall be joined with this A to get the top view of the line. So for that, select the line option. So since it is a visible line, the thickness should be 0.50. And from this endpoint A, we shall try to intersect this point of intersection, that is the locus line and also the arc that we have drawn. So this is the point of intersection, as you can see next to the cursor. So we are going to drop the line here, which marks the top view of the line AB. So measuring this shall give us the top view of the line AB. So this is AB. And then to measure the angle in the dimension, select the true length and the axis line. So this gives the true inclination as given in the problem statement. And selecting this line along with the reference line gives the apparent inclination. So 45 degrees and 55 degrees are the values of alpha and beta. 30 and 45 degrees are the values of theta and phi that is given to us in the question. So we can indicate the directions of the projection lines using the leader option. In the annotation, select the leader option, change the properties to black color, then click OK, and then indicate the direction of the projection lines. So this is in this particular direction, and then this projector is moving upwards and in the counterclockwise direction. So this is indicating the directions of the projection lines. So with this, we have completed the problem. So since the locus of A dash and A is lying on the XY line, we do not have to mention the locus lines. So just adjust the annotations properly so that it is not intersecting with any of the lines and it is visible clearly. So this is A prime and B prime, which is the front view of the line AB, and AB is the top view of the line AB. So with this, we complete the problem.